In this whole video series, we are going to discuss about 50 important points to improve SQL query performance. So what we'll do is we will first try to understand what is a SQL query plan. We will try to understand how to read a SQL query plan. We will then move towards understanding various physical and logical operators contained in a SQL query plan. So we'll try to understand different physical operators like physical and logical operators like table scan, index scan, what is good and what is not good at different situations. We will also look into fundamental concepts of clustered and non-clustered indexes and what are the best practices we need to follow when we choose a clustered index and when we choose a non-clustered index. We will then move towards some advanced techniques like indexed views using SQL Server Profiler, etc. So I'm sure that this whole series you will enjoy, and we would recommend that either you are a fresher or either you are a senior person, please do have a look at least have a glance at all of the videos contained in this series. So welcome to this video series, and I hope that you will enjoy this whole series. Before we move ahead, let's try to understand three important concepts. Query plan. So how do we read a query plan? How do we see a query plan for SQL? And what are the various factors we should be looking into the query plan? The second one is physical and logical operators. Whenever we read a query plan, it is comprised of physical and logical operators. So we need to understand basically what are these operators and how they influence your performance. And finally, we are going to use the logical reads to measure our query performance. So we will also try to understand what is logical and physical reads and how they differ from each other. So basically, this will lay out our foundation for SQL query performance improvement. Every SQL statement which you fire on the SQL server is broken down into series of execution process or execution steps. And these execution steps or process are called as iterators, or they are also called as operators. Now, for example, you can have iterator like aggregation, you can have iterator like sum, average, insert, update, delete. So iterators and operators are nothing but, they are basically logics which you need to execute that SQL statement. Now there are two kinds of operators slash iterators. One is the logical iterator and the other one is a physical iterator. So every SQL statement which you write on the SQL server will be comprised of logical operators, and these logical operators will in turn point towards the physical operator. Now logical operator is nothing but it's basically the conceptual plan. Okay, it's not the actual logic. So for example, let's say that you want to make an inner join, right? So the logical operation or the plan is to do an inner join. But how do you do an inner join? For that, basically you need to have the actual logic, and the actual logic is the physical operator. So for example, an inner join logical operator can be completed by either using a merge join, or it can be either completed by using a nested loop. So logical operators are conceptual plan, while physical operators are actual plan. Now one logical operator can point towards multiple physical operators. So in other words, whenever your SQL engine parses a SQL query and it says that, okay, this is the logical operation, depending on situations, for that logical operation, SQL engine can take up multiple physical operators. So for example, to execute an inner join kind of a SQL conceptual plan, it can either use a merge join or it can either use a nested loop. Now, there are many physicals and logical operators. If you go to Microsoft.com, if you go to this link, you can probably type this link you can pause the video and you can type the link on your browser and execute it. You will see that there are tons of logical and physical operators over here. Okay, so this page has a very detailed explanation of logical and physical operators. Now, in order to understand how a SQL plan is executed, it is very important to understand what are the various logical operators and physical operators which comprise that SQL plan. If you are able to understand that, then improving the performance of SQL query plan is just a piece of cake. So you can go to this page and you can see this various physical and logical operators. Now, for example, you can see the merge join. Now the merge join basically is a physical operator, and as you can see on the tutorial of MSDN, it is written that merge join is a physical operator, and merge join performs these logical operations. Like for example, it can perform an inner join, it can perform a left outer join, etc. So as we discussed, that logical operators, they form the conceptual plan, while physical operators, they form the actual logic which needs to be executed for the logical operator. So how do we see these logical and physical operators? How do I know that for a given SQL statement, what are the physical operators and logical operators which will be used to execute that SQL statement? So here's a simple demonstration of how we can see those operators. I have a simple SQL statement here called as select star from customers, and the customers table is just if you just execute this, it has a bunch of records which basically has a customer code, customer name, and a register date. Now, in order to see that how this SQL statement will be executed by the SQL engine, you need to use the SQL query plan. So in order to display the query plan, you see that there is an icon here. So write your SQL statement on your analyzer and hit this icon. I am circling my mouse to show you the icon. Now once you hit on that icon, it will display a tab called as execution plan. Now this tab basically shows you what are the different physical operators which are seen on the query plan. For example, here it is saying that it is using the clustered index scan physical operator to fire this SQL or to execute this SQL statement. Executing a SQL statement is a three-step procedure. So once you fire the SQL statement to the SQL engine, the first thing it does is it checks for syntaxes. It says that are all the syntaxes fine, is there any kind of a compilation error, etc. Once the syntaxes are fine of the SQL of your SQL, it basically generates something called as a query processor tree, and this query processor tree is fed to the optimizer. Now the optimizer, it looks at the query processor tree and says that which are the tables which are involved into this SQL statement. It takes those tables and it analyzes the data statistics. In other words, it analyzes that how much data is existing on the table, is there any kind of primary key on the table, and then does the table span over multiple SQL pages, etc. And depending on the data statistics plus the query processor tree, it generates an estimated plan. Now this estimated plan is later fed to the SQL engine for execution, and after the execution, an actual plan is prepared. Now remember that there is an estimated plan and then there is an actual plan. That's a very important concept. So if you go to your SQL engine and if you right click, you will see that there is a display estimated execution plan and there is a include actual execution plan. So these two are different concepts altogether. The estimated execution plan is just an estimate which the SQL optimizer analyzes before even executing the SQL statement. So it's a conceptual plan, or it's just a plan. It's not the actual thing which will happen during execution. While the actual execution plan is a different, it can be a different plan altogether. If when you execute a SQL statement, whatever was your estimated execution plan, it will try to follow that. But in case it finds something better to be done, it will actually change its plan. So the estimated execution plan can be different from actual execution plan while the SQL is running. There are two important attributes which we need to understand when we talk about SQL performance tuning. One is the physical read and the other one is the logical read. Especially the logical read is a very important aspect, and henceforth whenever we do SQL tuning in the coming of videos, we will be using this attribute, that is logical read attribute, as one of the important metrics to measure performance. So let's try to understand first the difference between physical read and the logical read. Now what happens is when you actually fire your SQL statement, it actually fires on the actual database, your actual physical database. Now SQL server allocates some kind of memory for SQL cache. So for example, records or tables which are been queried again and again, those records are stored into SQL cache. Now initially when you fire a SQL statement, there is a physical read which happens, and later this records or this data is placed on the SQL cache, and henceforth when you fire again the same SQL statement, it will try to read from the SQL cache. So whenever the data is read from the actual physical file, or whenever there is an actual hard disk IO input output, then it is called as a physical read. And whenever the data is read from the SQL cache, then it is called as a logical read.